Ladies and gentlemen, hello and welcome back once again to Inside Analysis. Your host, Eric Kavanaugh, here for a very special event. We're going to have a 5-minute drill from my good friend Paige Roberts on shift difficult problems left with graph analysis on streaming data. And after we do this presentation, we're going to record our radio show, Inside Analysis, which is the only coast to coast radio show all about the information economy. But first, let's dive in on the tech here. Paige, I'm amazed by this stuff. When I first heard about streaming graph, my initial response was, oh, wow, that sounds cool. Because I understand graph nodes and edges. It's an excellent way to find patterns and to find relationships between entities. A node, of course, is an entity. An edge tends to be a characteristic of that entity. So a car could be a node, or a green car, a red car, that would be the edge. And these graph databases are incredibly powerful for finding connections. And of course, Meta, used to be called Facebook, made this famous. LinkedIn with their graph underneath the covers. Lots of these big vendors have graphs under the covers. That's how they can show you, oh, you're also connected with X, Y, and Z, that kind of thing. So there are a lot of tremendous capabilities, but graph databases tend to be pretty slow. And so they're batch oriented. They have updates that then publish the results. And this is streaming graph. So with that, I'm going to throw it over to you. And we'll be hearing, by the way, from Sanjeev Mohan of Sanjmo and Alex Husky of ExxonMobil later on in the show. Paige, take it away.
All right. So I'm both going to talk about the shift left idea, which is an application of this technology, about the technology, and a little bit about the company, just to give you a general idea, because all of it is fairly new, I think, to everyone. So let's start with a story. It's like way back, we knew we had all of these problems that had to be responded to very quickly, that were very difficult, that required some pretty in-depth relationship analysis and the kind of analysis you were just talking about, Eric. But it was too slow to put them all the way, to go through all of the system and put them in the graph thing. So in order to find the answers, in particular, the problem that triggered it was advanced persistent threat in cybersecurity. Now, this is a concept where someone breaks into a secure system, usually a foreign government or a criminal organization or somebody like that, and they just sit there. They don't do anything for a long time. And the problem is that all of our cybersecurity software, and in fact, most of our event processing software, has time windows.
Mhm.
So if they wait until the time window expires, they can now do anything they want to, and they look like legitimate users. DARPA funded in 2015 and worked with Ryan Wright, who was our thatDot founder and director and the inventor of the Quine open source software. They worked with him to figure out how can we solve this problem. And that's how Quine was invented in 2022. The company was created, thatDot, which is our commercial version, and it's funded by CrowdStrike, Falcon Fund, and a lot of other folks that are really interested in that sort of thing. And the idea is it is an event stream processing capability with no time window. So I can query as far back in time as I want and query something that just happened and put them together and find the pattern that indicates this is a problem. This is something to worry about. And the reason I can do that is because we see all data as a graph. Just like a graph database, but without the slow factor. So we can ask categorical questions without turning them into big bloated numeric stuff first. We can ask deep relationship questions. We can find those patterns in the data, no matter how scattered they are. Now, one of the things that is a problem with graph technology is scaling it. And the big problem, the Achilles heel of graph, is supernodes. So if I expect most nodes to have about 100 to 300 edges, and I have one that has 10 million, it's very hard for me to then distribute that across a cluster.
Interesting.
So the Quine open source software does 1,000 events per second per CPU. So you give it a stronger machine, it's going to go faster and faster. It's going to do a lot. But if I need to go across a cluster, if I really have a high scale problem, we have actually defeated the supernode issue.
Wow.
At this point, we've been tested with over 100 million edges on a single node, and we still get sub 5 microsecond queries. Most microseconds are under, most queries are under a microsecond. So the three technologies I'm discussing are Quine, which is our open source capability. And then thatDot is the company, and Streaming Graph is our commercial cluster size, high scale, support, all the things that you expect from a commercial. And then thatDot Novelty, which is a little bit different. And I'm gonna skip this about how Streaming Graph works, and we'll talk about it more later. But first I'm going to talk a little bit about Novelty. So Novelty is a pattern learning AI built on top of this. So you don't have to train it. You don't have to label data. You feed it data. It automatically figures out what is anomalous in this data stream, what is unusual. And this is awesome for finding your unknown unknowns. The things that you didn't even know were a problem, discovering them that way is the best. And it's about 1,000 times faster than the next most commonly used anomaly detection. So that's pretty much the idea. Is let's shift this left. Let's not do this long, drawn out process that, you know, if we're really lucky, you know, you get it in hours, but a lot of times it's more like days. And shift it all the way over to do a lot of the work, a lot of the analysis right in the event stream processing system and get it in microseconds or seconds if it's really slow. Now, this has great applications in cybersecurity, obviously. It's also really good for smart filtering on the edge because it can resolve duplicates and things like that. And it can take this mountain of unimportant data and find the key important bits to pass them down the line. And of course, real-time risk analysis and fraud detection is pretty common. So that's kind of how it works. And
That's the 5-minute drill. That is absolutely fascinating. So shift left, the concept refers usually to moving it up the stack, upstream somewhere. And what you're able to do is dynamically ascertain new things that are happening, which of course might well be new bad things. It could be new good things, but it could be new bad things. The fact that it's new things, and your point about bad actors dwelling for 6 months to a year, that's how they get it done. I remember years ago, Dr. Robin Bloor explained to me that the whole narrative around bad actors of the hoodie hacker by himself, the lone hoodie, is nonsense. It's an industry, and they have different parts of the industry, different roles, and someone penetrates, they hand it off to someone else, then they sell that to someone else, and it's a whole workflow around this stuff. So they get in, and then they just wait. And like you say, if they wait long enough, they will outwait your windows. And then when that window restarts, you're already in there. You're just a known quantity as far as the new system is concerned. And that's the problem, right, Paige, real quick?
that's it exactly. Yes.
Wow. Well, our radio show is about to begin, folks. So I'm going to stop the recording.